Hey there, everybody. This is Max with the Libre, and I'm really excited to show you some cool stuff we've been up to today. We are upcoming on the release of 2019, and so this is kind of a celebration of that, something that we've been working on in the background and that we'll be releasing a little bit after 2019 is released. You'll see this is in 2019, but this will not be in the shipping version of 2019.0. So with that out of the way, let's talk about what we're talking about today. Everybody's been in this situation, right? You've got something like this, and it just goes right on through. You want there to be some degree of freedom. You want to be able to move it, but you don't want it to go through other parts. And this is something that you couldn't do until what I'm about to show you. And that's the basic idea of constraint limits. What we've implemented is a new kind of constraint. Right? So I'm going to start by just selecting these two. And normally you might mate them at maybe 0. And we'll preview that. And then that would create the mate, and the part would remain in place. And that would be of type equal. And this is a new kind of GUI here. This is not the final user interface. It's just kind of the development flavor. But what if we made this greater than 0? What would that behavior look like? Well, that means we'd be able to go anywhere above here, but the second we kind of try to make it go through, it's going to stop because it would turn negative if it went on the other side. Same principle might apply to this other one, right? If we want to make it greater than 0, then we would be able to do this in both directions. So you can probably already see the power that this gives you in terms of way more realistic simulation of your mechanisms and just your products in general. The next example I might show would be something common like this, right? If you're making pistons, the range of motion of whatever's attached to these pistons, if we're going to go to something like this, is where this assembly can go and how it can move is very much dictated by, the piston position. And if you have pistons going all over the place through other parts, that's not going to give you a very realistic simulation. So why don't we try something to see how we can constrain this? So we'll do the standard constraint, and why don't we do an advanced selector, and we'll select, looks like I didn't get that face. Okay, we got that guy, and we got this guy, right? And similarly to last time, we want to make sure that, this never goes, perhaps maybe within half an inch of each other. So we're going to say 0.5, and we'll say greater, and we'll apply. Right? So right now we're greater than 0.5, but if we try to move it past 0.5, it's going to stop. Now, the last example that we used, we kind of constrained two sides of the thing, and we could do that this time. We could, this interior face of the cylinder and this top face of the piston, we could certainly, make that perhaps greater than 0.5. But there's other ways that we can approach this. We could, for example, change this to be a between relationship, right? So we want it to be between 0.5 and, I don't know the right number, but let's say 12. That looks about right, right? So there's different kinds. There's greater, equal, less, and between. And everybody's used to the equal relationship. That's kind of the default behavior. But the new ones are going to be greater, less, and between. So you can start to see now we're starting to limit our range of motion appropriately. And I'm sure you can kind of start to assume the power that this is going to give you and the realism of mechanism simulation that combinations of these things are going to give you. So, a quick example of where you might run into something like this is going to be, this lamp, right? It's got tons of constraints. You can do all kinds of wonky stuff with it. That's not desirable, right? We can go through the base. Everything can kind of overlap each other. When we start to apply this concept of, more rational constraints to the mix, we start to get, a much more interesting mechanism, right? So if it stops where it's supposed to, we don't get these kind of overlaps anymore. I'm kind of at a weird angle, so it's going over all over the place a little bit. But, you can see that I can't really get it into that same kind of bad state that we can easily get something into here. So that's about it, guys. I hope this is really exciting because we're super excited about it. This will probably be launching within 3 to 4 months, along with a bunch of other cool stuff. So keep your ears to the ground, and we'll talk soon. Have a good one.